Alright, on the next homework assignment that covered sum and difference and double angle identities, there was about 7 questions that you guys requested that we hadn't had a chance to go through, all from the Sullivan pages. So this one we need to find the exact value of each of these 4 expressions: sine of alpha plus beta, cosine of alpha plus beta, sine of alpha minus beta, and tangent of alpha minus beta. Alright, here we go then. If the sine of alpha is 5 over 13, and we're located inside this domain, let's see what we can find out about the cosine of theta. So let's draw a little diagram of our situation. We are in between negative 3 pi over 2, so that's negative 1 pi, negative 2 pi, negative 3 pi over 2, and negative pi. So we're somewhere in this region right here. So let me draw my angle. That's in between negative 1 pi and negative 3 over 2 pi. And we know that let's always draw a vertical line in order to complete the triangle. The sine of the angle is y over r. So there's our 5 and there's our r. And a little bit of Pythagoras, we'll find out that this x value is equal to, of course, negative 12, because we can see the quadrant we're in. So x is negative 12 right there, and that must mean then that the cosine of our alpha value is going to be equal to adjacent over hypotenuse. That's negative 12 over 13. Let's do a similar process just to figure out some information about the angle beta. And so we can see that tangent is negative. That must happen in either quadrant 2 or 4. And it tells us that we're inside quadrant 2. We're in between pi over 2 units and pi units. That brings me around to there. So again in quadrant 2, tangent is, we know, y over x. And so we're going to have this positive y value of root 3 over this negative x value of negative 1. That gives us the negative root 3. And then a little bit of Pythagoras. This is r. We know that root 3 squared plus negative 1 squared is r squared. This means that r is equal to plus or minus 2, but of course r is a distance, so r must be 2. And so, let's see, that means then that our sine of beta is going to be opposite over adjacent, root 3 over 2, and cosine of beta is adjacent. It's negative 1 over 2. Now we've got all of the information, and you remember, by the way, that we were given sine of alpha right at the beginning. Now we've got our sine of alpha, cosine alpha, sine of beta, cosine beta. We should be able to answer all of these questions. So part A, the sine of alpha plus beta, according to our identity, is sine alpha cosine beta plus sine beta cosine alpha. So let's substitute. Sine of alpha is 5 over 13. Cosine of beta is negative 1 over 2. Sine of beta is root 3 over 2. And cosine of alpha is negative 12 over 13. So that gives us negative 5 over 26 minus 12 root 3 over 26. Let's put it all over a common denominator of 26. Part B asks us for the cosine of alpha plus beta. That's going to be the cosine alpha cosine beta. Take the opposite sign, minus sine alpha sine beta. And again, we're just going to substitute. I assume that you can do that. C, we know that the sine of alpha minus beta becomes the sine of alpha cosine of beta minus the sine of beta cosine of alpha. I'm sure you can substitute from here. And the tangent of alpha minus beta is going to equal the sine of alpha minus beta, which we just found, over the cosine of alpha minus beta. So I suppose we could take it one more step and say, right, well, that's going to be the sine of alpha cosine of beta minus sine of beta cosine alpha all over cosine alpha cosine beta opposite sine sine alpha sine beta. And you can substitute from here in order to solve for the tangent of alpha minus beta. So that's how to do number 35. Here's number 51. We need to prove this identity. So let's start on the left-hand side. Got the tangent of pi minus theta. That equals the sine of pi minus theta over the cosine of pi minus theta. So now let's apply our difference formulas. That's going to be sine beta cosine alpha minus sine alpha cosine pi. Sorry, I think I said theta. I meant, hope it's clear. Cosine pi cosine theta, opposite sine, sine pi, sine theta. Now pi is located right here, and so we can see that sine is going to be right in between a positive quadrant and a negative quadrant. We're 0 radians away from the x-axis, so that indicates to us then that the sine of pi must be equal to 0, and the cosine of pi, we can see that we've got a positive quadrant, so cosine must be positive. 0 degrees away, cosine of 0 is 1, so positive 1. Another way we could see this, of course, would be to look at your graphs of sine. We can see that at pi we're at 0, and at cosine we can see that we're at negative 1 before we go through the other half of the cycle. So let's make those substitutions. Sine of pi is 0. Cosine of pi is negative 1. Plus 0 times sine of theta. The zeros are going to make some things disappear, and I'm left then with sine theta over negative cosine theta, which equals negative tangent of theta. We're finished. Number 62. Alright, we can see on the left-hand side that we're going to be dealing with some cosine of sum and cosine of difference identities. So here we go. Cosine alpha, cosine beta. Opposite sine, sine alpha, sine beta. And in the denominator, I've got cosine alpha, cosine beta plus sine alpha, sine beta. Alright, now what can I do? I think at this stage I'm going to sneak a peek at my right-hand side. I notice that my numerator is a difference, like this numerator. My denominator is of sum, like this denominator. So what could I do to each of these terms to make it look more like this? So how could I make this cosine expression equal to a 1? Well, what if I divided it by itself? Then it would become a 1. But if I divide this by itself, I've got to divide everything by this. Well, that will create a 1 right here and a 1 right here. That's good news so far. And what happens when I've got sines divided by cosines? I get tangents. So let's divide every single term here by cosine alpha, cosine beta. If I've divided the top by cosine alpha, cosine beta, then of course I've got to do the same to the denominator. Alright, let's look at what we got then. The numerator becomes 1 minus sine alpha over cosine alpha is tangent alpha. Sine beta over cosine beta is tangent beta. In the denominator, pretty much the same thing. And there you go. Next question. Now, this is the last one I think that you asked for on page 634. So we need to use these figures to evaluate the function given f, g, and h. Here we're only working with h. So h2 theta, that is to say tangent of 2 theta. I wonder what they mean by me using the diagram. Let me first write it out as sine 2 theta over cosine 2 theta. And so that's going to equal 2 sine theta cosine theta over cosine squared minus sine squared. And now looking at my diagram, if x squared, which looks like, is that a value of a? I think that looks like an x value of a, doesn't it? A y value of 2. And x squared plus y squared equals 5. That must mean then that the radius, r squared, if I do x squared plus y squared equals r squared, that must mean that our radius is equal to root 5. So now I can see then that a little bit of Pythagorean work will be able to figure out that the a value is equal to -1. And so then the sine of theta must be the opposite side over the hypotenuse, while the cosine of theta is going to equal the adjacent side over the hypotenuse. So now I should be able to substitute these values in. Sine, cosine, and the denominator, cosine squared and sine squared. Alright, that resolves and gives us a numerator of -4/5 divided by a denominator of 1 over 5 minus 4 over 5. And so our -4/5 in the denominator must multiply by the reciprocal of -3/5. And the 5's cancel and the negatives cancel. I'm left with 4 over 3.